Today we're going to try to find the tension at ropes 1 and 2. As you can see here, 1 and 2. This is 65 degrees, 40 degrees, and 11 kilogram box. So to start out, we can separate our X and Y directions because we have two different triangles, as you can see here. This is the first one. This is 40 degrees, T1X, T1Y, and T1. So we're going to try to find the tension in both ropes, and the best way to find it is to find it separately. So here's the first tension, and here is the second one. This is 65 degrees, and this is the tension 2 rope. The reason we find them separately is because we cannot find them at the same time. So we break up into X and Y direction, and we start out by saying that cos of 40 degrees minus sine of 60 degrees is equal to 0, because we know there's no gravity in the X direction. So now we pass the sine to the other side, and we will have this equation. T1 cos 45 over sine of 60. Now that we have gotten to this point, we cannot move anymore because we don't know what T1 is. So we can move on to the second one. And we know that T2 cos 65, 65 plus T1 sine 40 is equal to the gravity. And we know that gravity is 11, the weight of the box, times 9.8, which is equal to 107.8. So we will set it equal to 107.8. And then we know that we can plug in this into here. So now our new equation will be cos 40 degrees over sine of 65 degrees times T2 cos of 65 degrees plus sine of 40 degrees is equal to 107.8. So this is our new equation. We just plugged in what we got in the X direction into the equation we got for the Y direction. Now we're gonna solve, and we know that T2 cos 40 degrees times cos 65 degrees over sine of 65 degrees plus sine of 40 degrees is equal to 107.8. And now we plug all of this into our calculator, as you can see here. So it'll be cos 40 times cos 65 is equal to this divided by sine of 65 plus sine of 40, and the answer is 1.19. So we write 1.19 is equal to 107.8, and then we